Hey Algebra, we are doing 9.4 today, and this assignment will be due Wednesday. So it's solving quadratic equations by factoring. And we kind of know how to do some of this, but some of it will be new. So I just wrote that. It's on page 588. Of course, I don't have my book with me, so that doesn't help me out at all. But hopefully some of these problems, a lot of these problems are straight from the book, from examples, so you can kind of follow along that way. First thing we're going to talk about is the square root property. And I usually don't teach the square root property that much just because we've kind of used it a lot up until this point, but I'm still going to go over it. It's just saying that anything in the form of x squared equals n, so x squared equals something, you can solve it by taking the square root of each side. And that's the square root property. So for instance, we have x plus 6, and that's squared, equals 81. Well, this is in this form already, so all we need to do is take the square root of both sides. Now when you take the square root, this becomes plus or minus. So I have x plus 6 on this side, because the square root undoes the squared. And then I have plus or minus the square root of 81. Well, you probably know that would be 9. Okay? So what we have here now is two different equations because x isn't by itself yet. So we need to subtract 6. But are we subtracting 6 from a positive 9 or a negative 9? Well, we're doing both. So you're going to have a positive 9 minus 6 and a negative 9 minus 6. Okay? So x equals that and x equals this. So 9 minus 6 is 3. And negative 9 minus 6 or plus a negative 6 is negative 15. Those are your answers. It's always a good idea to check and make sure it'll work. So if I put in a negative 15 and I add 6 to it, I get negative 9, and when I square that, I get 81. Same with 3. Plug that in, I get 9, squared is 81. So check your work, it helps. Let's do this one. Well, I need to get it into this form here. So that just means I need to add 3 to both sides. So I have x minus 8 squared and equals 13 now. So now I need to take the square root of both sides using that square root property. So I have x minus 8 is equal to plus or minus the square root of 13. Well, this is an irrational number. There is no perfect ending decimal for the square root of 13. So some of your book says to round, but I want exact answers. And honestly, it's easier this way. So when you get down to a square root of 13 or something that doesn't work like that, you can just leave that. But we still have to get x by itself. So we need to add 8. So a lot of times you're going to see an add 8 like this, and this be your answer. But let me just explain where that add 8 should be. Okay? The add 8 is appropriately put before the plus or minus square root of 13. So how I would like for you to write your answer would be this. Now you still have 2 answers, but I'm not asking you to figure those out to the approximated decimal. But if you had to, like in real life problems, which we'll do later, you will want to because you'll need to round to the nearest second or tenth of a second or something. But this is saying you have 8 plus the square root of 13 and 8 minus the square root of 13. And both of those would fit right in there. Let's do this one. In order to get this into the x squared equals n form, you need to divide by 4. When I divide by 4, I get x plus 1, quantity squared, equals 9. If I take the square root of both sides, I get x plus 1 equals plus or minus, and the square root of 9 is 3. So now I need to subtract 1. And again, am I subtracting 1 from a positive or a negative 3? Well, you have to do both. So x is going to be a positive 3 minus 1, which is 2. And x is going to be a negative 3 minus 1, which is negative 4. If you're bad with your adding and subtracting negatives, make sure you use a calculator. Then let's take a look at this real life example. And I'm bringing this up because this is one of those where it's the ball being dropped and you have a quadratic. And this is a common formula you're going to come across. So we're just going to use this and realistically try to come up with the answer. So it says, during an experiment, a ball is dropped from a height of 205 feet. The formula is this, and it can be used to approximate the number of seconds, which is t, it takes for the ball to reach the height, which is h, from an initial height of h sub 0. Find the time it takes the ball to reach the ground. Okay, so we have this formula, and h is the height that we want to know, like how long it takes to get to this height. Well, we want to know how long it takes to get to the ground. Well, how high is the ground from the ground? 0. So I'm going to take I'll rewrite this. So I'll take my h and I'll put in a 0. We're solving for t, so we don't know t. And my h sub 0, that's an initial height. Well, he dropped the ball from an initial height of 205 feet. So we're going to add 205. The last thing we need to do, well, not the last thing, but we need to put it in the x squared equals n form. So to do that with positive numbers, we can just add that 16t squared to this side. So it's going to look like 16t squared equals 205. Now let's start solving. Let's divide by 16. Um, 12.81, that's what I get. Okay, so t squared is approximately, I get like 12 point, oh, what do I get? Whoopsies. 0.8125. And we have to take the square root of both sides. So when I take the square root of that number, I get positive or negative 3 point, I think the book rounds it to the 10th. So 3.6 seconds. Now that means in a positive 3.6 seconds, the ball will reach the ground, or in a negative 3.6 seconds, the ball will reach the ground. Well, this is where you have to think a little bit realistically, and hopefully none of you are going back in time, so it's going to be a positive 3.6 seconds, and that's going to be your answer. Ta-da! Let's move on to, I think that was all on this page, yep, to page 590, where we talk about solving by factoring. Okay. So the zero product property is something you'll hear about a lot, and I know I've mentioned it a little bit already. It's saying that if the product of two factors is 0, then at least one of those factors has to be 0. In other words, or in algebra words, if x times y equals 0, no matter what x is, no matter what y is, then either x has to equal 0 and or y has to equal 0. That's not a y. Whoa. Whoa, that's crazy. There we go. I don't know what I pressed. Okay. So we're going to use that concept to find the answers in quadratic functions. Now do remember from your graphing to solve quadratic functions where the graph crossed the x-axis, your roots, your zeros, those were your answers. That's how you solve it. Okay? So what we're going to do is set these equal to 0 and solve. Most are going to have 2 answers. Some will not have any, and some will only have 1. Okay? So just a quick reference. Whoa. When you're graphing, if your graph kind of went normal like this, you had 2 answers because they both crossed. If your graph was up here where it didn't cross at all, then there was no answers, no solution. And if your graph just touched right on the your vertex just touched right on the x-axis, then there was only 1 solution. Just a refresher. Okay, so this example here, they're set up already where you have 2 factors set equal to 0. So this is a factor and this is a factor. Now remember, 2 factors equal to 0, well you can break them apart and set them each equal to 0. So I'm going to write 2d plus 6 equals 0 and or 3d minus 15 equals 0. And I'm going to solve both of those. So I'll subtract 6, 2d equals negative 6, and then I'm going to divide by 2. So I have d equals negative 3. And on this side, I'm going to add my 15 and divide by 3, so d equals 5. So those are my 2 answers. I have 2 answers, 3 and 5. Ooh, I don't want to do that. Let me see. And I'm going to give myself way more space. Okay, here is another one. C squared equals 3c. Well, it's a quadratic. Whenever you see a quadratic and you need to solve it, you should think, oh, I should set that equal to 0. Okay? Unless it's in the form of the square root property, the x squared equals n. So there's no bx term, no middle term. Here, there's a middle term, and the a term and the b term, and there's no c term. So this, you're definitely not able to use the square root property because you can't take the square root of a c. So let's subtract it so you have 0 on one side. So c squared minus 3c equals 0. And let's start factoring. Let's see, if I can take out a c, I'm left with c minus 3. It might have been a while since we've done this. And now I have 2 factors. I have a c and I have a c minus 3. You can think of it like this if you want. Okay, so 2 factors. So we're going to have 2 answers because we're going to set each of those equal to 0. So I'm going to say c equals 0 or c minus 3 equals 0. Once I add 3 to both sides, c equals 3 is one of my answers, and c equals 0 is the other one of my answers. Here's another one. Sorry, I'm just trying to get a different ink color. All right, we'll try that. So this one's already factored out. You have 2 factors here, 3n and n plus 2. So I'm going to write 3n equals 0 and n plus 2 equals 0. When I solve, I get negative 2. Again, seriously, quit doing that. So n equals -2. And n equals 0, because when you take 0 and divide by 3, it's just 0. So those are your two answers. Here's one I'm going to factor out of, well, what is my GCF? 8b. So if I factor out an 8b, from 8b squared, I'm just left with b and minus 5. So again, these are two factors. I'll set them each equal to 0. 8b equals 0, which when I divide by 8, I just get b equals 0. And b minus 5 equals 0, which when I add 5, I get b equals 5. So my two answers there. X squared equals 10x. Well, it's quadratic. I should get it equal to 0. So I'm going to subtract 10x. So I have x squared minus 10x equals 0. And then I'm going to factor out an x. And then I'm going to set each of those factors equal to 0. Whoops. So I have x equals 0, and I have x equals 10. One more page here. This one, we need to actually factor the quadratic trinomials before we set them equal to 0, because these ones are the ones where you do the groupies, you know, factor into binomials. So I thought I'd just kind of refresh your memory on some of these and go through them. So let's take a look at this first one. This is a quadratic trinomial in the form of ax squared plus bx plus c. So we know we should be able, if we can factor it, we can factor it into binomials. It's kind of messy. So two numbers that multiply to a -24 but add to 5. Well, I think we're going to have to go with a +8 and a -3. Because 8 times -3 is -24, but 8 plus a -3 is a +5. So now you can set each of those factors equal to 0. X plus 8 equals 0. X minus 3 equals 0. And by now you're probably pretty good at solving these in your head. X is going to be either -8 or a +3. This one, we need to subtract that 9x first. So it's going to be 3x squared minus 9x minus 12 equals 0. Well, it looks like we have a GCF of 3. So I'm going to factor out a 3. And I'm left with x squared minus 3x minus 4. Then I'm going to factor this trinomial in here. So I still have my 3 technically. I need two numbers that add to or multiply to a -4, but add to a -3. So I'm going to go with -4 and a +1. Okay? So technically I have 3 factors that I can set equal to 0. So I can set 3 equal to 0, but I think you guys know that's not possible. So I usually just drop that without even thinking about it. But then I have x minus 4 equals 0 and x plus 1 equals 0. So my solutions are going to be a +4 and a -1. This one here, I think I'm going to add x squared to that side. So I have 49 equals x squared. And then I can take the square root of both sides. And you can rewrite it so the x is on the other side or whatever's more familiar to you. But it looks like x is going to be a positive or a negative 7. And you can write it like this if you wish. Or you can write positive 7, negative 7. Doesn't matter to me. This one down here looks like I first need to subtract 45. Okay, which leaves me with 25x squared minus 60x plus 36. I am not sure the GCF of that. Ugh, that's nasty. So I think we'll have to use the swing method. So I'm going to take 25 times 36, which is 900. So I have x squared minus 60x plus 900. That was my swing method. Luckily, it's not quite as nasty as it looked like it was going to be. So I would think 30 and 30 make 900. So they have to add to negative 60. So I'm going to go x minus 30, x minus 30 equals 0. So you have two factors. You can set them equal to 0. Either way, you're just going to get one answer, which is 30. So x minus 30 equals 0. Once I add 30 to both sides, I get that x equals 30. So what that's telling me is the vertex lies on the x-axis because there is just one answer. The last one I'm going through today for this lesson is this one. So I'm going to add 21 to both sides, which leaves me with x squared minus 13x and 36 equals 0. Well, let's see if we can factor this nicely. I think 9 and 4, x minus 9, x minus 4. So set those equal to each other, or I'm sorry, set them equal to 0. So x equals 9 and 4. And remember, you can always plug these in to make sure they work. I can plug in a 9 for my x's and make sure it works out. I can plug in a 4 and make sure it works out. Well, that was a 23-minute long lesson, so hopefully it helps. And we'll be moving on. This assignment will be due on Wednesday. I think I said that. And then 9.5, that'll be due on Friday. So let me know as you have questions. Thank you.